Hello. So I've had a few people ask me about this animation, and I figured I would do a little breakdown of how I set this up using mostly Copernicus and a little bit of Pyro for this morphing effect at the end, and very little actual modeling, because who wants to deal with that? This won't be a full step-by-step tutorial because I think that would just take too long, but I'm going to assume you have some working knowledge of Houdini and you've used Copernicus maybe once or twice before. And if that's the case, then this should be fairly simple to follow along with, I imagine. So let's get to it. Here's our final result inside of Houdini. So let's start. Actually, it's not the full final result because it's missing the rim, which we might as well start with. So we'll be building this thing first. As you can see, it's basically one design copied 5 times, and then the design itself is symmetrical as well. So really, all we have to design ourselves is this little slice here. And then we can mirror it and copy it 5 times over. So let's get to it. First, we'll need some base geometry because this is all displaced geometry. So we need a base circle to start with, and then we'll be displacing that using our output from Copernicus. So the way I did this was I started with a planar patch, and what I would like is quite a dense distribution of quads along this surface, which sounds very simple, but it took me a minute to figure out the best way to actually get that done. Because if you use the quad remesh at its default settings, which is a decimation level of 1, you get this nonsense here. Cranking it up to 12 takes care of that, but it's still, it's just not great. So I added a smooth with a very high strength, 5,000 in this case. And this isn't perfect, but it's plenty good for our purposes right now. So we'll dive right into Copernicus from here. That's all the modeling we had to do on the rim. Just give it a second here. All right, so this is our final output from Copernicus. So this is the height map, which we'll be using to displace the geometry we just created. And this network might look a bit overwhelming, but honestly, it's very straightforward. It's some very basic 2D operations repeated over and over. So I started out with something that looks like this, which is it's just a simple Voronoi operation. Just remapped it, gave it a little bit of blur, dilated it, and threw this fall off on top in a blend node, just so there's some fall off towards the middle and then some fall off towards the edge here, which will come in handy later. And that's really all it is for this whole part. So as you can see, it's really not that bad. The next part is noise with a little bit of blurring on it, blended together with another noise, which gives you this. Honestly, I was just messing around here and tweaking settings until I came up with something that looked good to me. I didn't have this all planned out going in, obviously. So this is the output from that node, and at this point I just want to constrict it to that one pizza slice that we were talking about before. So I'm bringing in a quick slice from the SOPs here, just a circle that I carved to 0.1, which will give us 10 segments in total, and adding a point, adding these points together, and just getting rid of this open curve there using a prim intrinsic function check. Honestly, it doesn't matter if you're rasterizing anyway, but it's good practice. So rasterized geo, now we have a nice little mask for our slice. So I'm just taking that previous design, multiplying it by the slice, And that's most of that done. So now we mirror it, form a couple more operations, and a little edge detect here, some sharpening, I think. And what else? Okay, yeah, so I added some bolts to this thing in case you didn't notice initially. I'll just show the design again. There you go. We got these 5 bolts in the middle, so easy enough. You take a circle and you take a hexagon, whoops, and you multiply them and just throw it in there. See what happens. At this point, 1/5 of the whole rim is done, so I just need to do a little copy and transform, which is what you would normally do in SOPs. The way I did it in COPS is I made a pentagon and gave it normals so that the slices are oriented correctly. And then just made it really, really small and use that as my input for the stamp point cop. And there you go. That's the design done pretty much. Again, a few extra operations, just some sharpening. And that's it. Oh, great. Well, I guess OpenCL just crashed, so I'll pause it here and restart Houdini. There we go. We have our height map back. So that's basically it for this part. We're going to apply this to our mesh now. Before we can do that, we need to give this some UVs. So just drop a simple UV texture. I'll take care of it. And promote your UVs to points because we'll be working inside of a point VOP. Then I'm dropping a subdivide, which will dial in the level of detail for our final rim design. For now, I'll just keep it at 1, just for performance's sake. And then we're diving into the point VOP where we're doing the actual displacement. And what we're doing in here is quite simple, really. You need a texture VOP, obviously, because we need to bring in our Copernicus output. And the easiest way, or most foolproof way, I guess, is to just go back to COPS, select your final output, Control-C to copy. Go in here, go into your texture map path, paste, and just add OP colon in front of it, or it will not work. And if you don't have the rest of this plugged in, you can easily check whether the map's coming through correctly by putting it in your CD channel. And as you can see, there it is. So that's working. So instead of putting it in CD, we're going to just put it into the amount for the displace along normal VOP. That's this guy. And position goes into position. And then you just have to feed it a normal direction, which in this case is going to be our y-axis. So 0, 1, 0. That should suffice. And then I'm adding a parameter here just so I can control the displacement amount and plugging it into scale. And then the output of this goes into P. And there you have it. This looks like crap, obviously, but that's what this subdivide was for. Crank it up and it gets a lot cleaner. Maybe we'll leave it at 2 for now. Maybe 3. Let's see how it goes. If it's too much, then we'll turn it down. All right, so next step is to clip this, which gives you that open rim effect, I guess. Deleting small parts just in case, depending on the output from your Copernicus node, you might be left with some weird floating chunks. So this will take care of that. And then very simple, just mirroring it so that we have both sides, merging it with an outer rim. At this point, you could VDB the whole thing, but I ended up not doing that because I was pretty pleased with the result as it was, and VDBing it just added more polys to what's already a high poly workflow. So I figured this is fine as it is. Last thing I wanted to do was to add a little bulge in the middle here because this is perfectly flat, which is not very rim-like behavior. So the way I did that was to measure the length of all the position vectors. I'll just get a visualizer going for the mask. And then I inverted that mask by fitting it. And that's this basically. So now it's running from 1 in the middle to 0 around the edge, blurring it a tiny bit, and adding the bulge, which is just a simple position ramp using the previously created mask attribute. And again, easily controlled this slider here if you really want to go crazy. Rotating it so it's upright, and that's the rim. Now this is the part where the power of Copernicus really comes in for me anyway, because you don't have to be stuck with this design. This is a completely random thing that I generated, and I thought it looked good, so I kept it. But you can always change any parameter you want. Maybe you want to try a different noise type, and now your rim looks completely different. Well, somewhat different, I guess. All this stuff is still going to work the same way. It's still going to be masked by these slices, mirrored, copied 5 times over. So you can go crazy in here, and it will still be a fairly cohesive thing in the end. Just try one more setting just to give you an idea. Kind of strange things that can happen when you start playing with Copernicus in a modeling workflow. So yeah, this is the fun part. Whoops, sorry about that. There we go. Maybe that's what you wanted. Well, here you go. Just play with the sliders. All right, we'll leave the rim for what it is and move on to the tire, which is going to be a little bit more involved. So what do we have here? Well, we have a very basic tire shape, which is segmented into 1, 2, 3 parts. Basically, we have this sidewall here, we have this sidewall here, and we have the main surface of the tire with this typical off-road profile. Maybe not very typical, but that's what we have. So we're gonna model a very basic tire. This won't take too long, and then set up our UV islands properly. After that, we will be following mostly the same workflow as we were for the rim. So this is just another displacement happening here. Same goes for the sides. So yeah, let's take a look here. Starting with a circle again, very simple, and creating a profile line, resample it, make sure you output curve view so that you can ramp it, get a little shape going like this, and use that in your sweep as the profile. At this point, I'm splitting the stream because I have to perform 2 separate operations here. One of them is a very simple one, and that's just creating this part. And the other one is a bit more complicated. You don't have to do this. You can do it manually, but I wanted a procedural setup for this. So I'll be setting up groups that will determine where the UV seams go. And I wanted to have a procedural way to set up the seam for the sidewalls, which is this guy over here. I wanted to be able to move this in case I decide that the sidewall design needs to be bigger or smaller. I didn't want to have to go back, manually reselect my edge loops, worry about losing them again once I remesh my model, etc. So I set up a little procedural method for this where I can slide my seams basically. It's quite simple. The way I did this was to just get the unshared points for this whole mesh, get rid of the unshared points in the middle, expand this group, and output a step attribute. So at this point, it's set to 8 steps. And then in a wrangle, I'm checking to see the step attribute. And if it doesn't match the output of the steps here, so the number 8, then it's excluded from the group. So now, whatever amount of steps I input here, I'm only going to get that edge loop, the edge loop that matches the step attribute. I hope that made sense. But yeah, here's the wrangle again. All right. deleting some attributes, merge, fuse, mirror, simple stuff. Getting the unshared groups again, extruding them a bit, because I wanted to get this little lip on the inside. And that's, I think, most of the tire model done. At this point, I want even quads. So obviously, if you have the exo-side quad remesher, it's vastly superior to Houdini's native quad remesher, but quad remesher should be fine. Yeah, you know, it's a little dirty. Smoothing will help. Again, if you can use the exo-side, use that. If you don't want to spend money on it, just use the quad remesher that's native in Houdini. All right, transferring my seam, mirroring, so we have seams on both sides. Getting rid of that extra edge loop in the middle here. Getting my groups, adding an extra seam here, promoting them to edges, UV flatten, which gives me this, a quick UV layout, just in case. So these are our sidewalls, the top two, and then this one, the big one, is our main surface. Doing a connectivity by ID, a connectivity by UV, and saving it as an ID attribute, because this will be very handy once we go back into Copernicus. Speaking of Copernicus, here's one thing you have to keep in mind when you're working with IDs. If the ID is set to 0 and you use the ID to mask cop inside of Copernicus, it's automatically going to assume that 0 is the background and it won't rasterize that part of your mesh. So make sure your IDs start with 1 and not 0 if you don't want to lose them. So that's what I did here. I just added 1 to the ID, so now I have ID from 1 to 3. And this will be important in a minute. Rotating it upright, and it's our basic tire. Okay, so I'm gonna do the sidewalls first just to get that out of the way, because there's gonna be a little more to do for the main surface. So the sidewall design is just something that I made in Illustrator, and I brought it into Houdini using the trace SOP, which is very useful and does a surprisingly good job most of the time. So yeah, I guess you could do this in cops as well if you're a masochist, but yeah, just use any other app, Illustrator or a free alternative. Okay, so I need to fit this design to my sidewalls. And in order to make life a little easier when it comes to that, I've split my vertices, promoted my UVs to points, and set my UV to P. So now these are my UVs in world space at this point. And now I can blast away the main surface and run a little loop on both of these that takes our design and matches it to the island. Does the same for the second one, except it rotates that one by 180. And then we just put them back in the original position. So now if I overlay my design with my UVs in world space, they match nicely. And this will save you some hassle once you're going into cops, because if you're resizing stuff inside of cops, it's not automatically going to adapt to the UV islands and you'll be doing a lot of manual tweaking. So this was a workaround that I figured out. I don't know if it's the most efficient one. If anyone has a better idea for this, then I'm all ears. So that's the sidewall design. And we'll move on to the main profile now. So we have our main tire model once again, subdividing once again, and I will turn this down a little bit, promoting UVs to points once more, and this is branching out into the displacement, but we won't be doing that quite yet because I want to set up the Pyro sim first. So this morphing effect is controlled by a Pyro spread. It's not a complicated Pyro sim at all, very basic. We're just going to start at one point, start spreading out across the tire and go from there. There's going to be a secondary effect involved, but I'll get to that after the main Pyro sim. So first off, we need to initialize our mask. Just set it to 0, that's fine. And then we're going to branch off here and set up the Pyro. So I'm getting rid of all the attributes. I don't need anything for now. Just P is fine. Setting up Pyro source, and your mode here, initialize source burn is fine. All you need is burn and temperature, basically. Dial in the particle separation that you want. I use 0.02 here. This might be default, actually. Setting up a start group for the source to start spreading from. Set a temperature of 1 and start burning at this point. Very simple spread with some cooling. And the cooling is quite important here because you want it to settle down a bit. So you can see the red areas are very hot. They're going, let's see, they're going up to 3, but then eventually things cool down to 0.8. And this is important for the settling effect that we're getting here. As you can see, when I play this, it's the effect is very pronounced initially, but after it's been pushed out very far, it ends up settling into the final design of the tire. And that's all controlled with the temperature. So first we push it out very far and then we let it cool down so it pulls back in. I assume that makes sense. So I have a cooling rate of 0.138 here, and you'll see that if you look at the final temperature, it's 1 minus 0.138. So that's how that works. Anything else that's important here? I turned on the noise because otherwise it's just a little too uniform for my liking. And with the noise, it feels a bit more organic. I think that's it for the Pyro spread, really. I'm blasting points that haven't burned yet, just to keep things clean. And I'm renaming temperature back to mask, caching it, transferring it back to our original design. So now if we visualize mask, you'll see the Pyro spread happening on our tire. It's a little chunky, so take care of that with a attribute blur. And now we can use this as a driver for the displacement. At this point, I want to get into the secondary effect that I was mentioning a minute ago, which is happening. It's happening around the rim. You can see as the spread is happening on the outside of the tire, the inner part is being pulled off of the rim momentarily and then settling into it as well. And this is, it uses the same Pyro sim, but it's a separate effect, so we'll have to set it up separately as well. Yeah, so I was using the mask attribute previously. I'm going to be using an attribute called peak for this, which starts out as the exact same mask. I'm getting the unshared points here in the middle because that's where the effect will be applied. Getting the distance along geometry. I'm getting the distance from these points to all the other points, basically. So it's running from 0 to 1 to 1 back to 0. Now I'd like to normalize this because there's a big chunk of 1 here and then it's not very evenly distributed. So you can use the labs attribute normalize float for that. I'll give you a nice normalized attribute. And I also ended up remapping it. So instead of 0 to 1, I wanted 1 to 0 because I want the effect to be the most pronounced right here at the start. And I don't want any of it happening here. Blurring it. And what are we doing here? This is basically a displacement. So you can see the effect already. Let me just turn up this amplitude here so it's more pronounced. Now you can really see the effect. So yeah, we're using this this dist attribute, the distance along geometry, multiplying it by a direction, which is just a normalized position of these points so that the effect is pushing outward away from 0, basically, and multiplying it by an amplitude slider. And this should follow our Pyro sim nicely because it's it's built from the same attribute that we output with the Pyro. So we have our secondary effects set up, we have our Pyro spread set up, and we need to, of course, we need to design our main profile still. For the sidewalls, it's going to be very simple. So here's our sidewall design brought in from COPS, from SOPs into COPS. And this is already matched to our sidewall islands, so we don't have to worry about moving this stuff around. And from there, I'm just rasterizing it, remapping it a little bit, performing a few more remapping operations, but it's nothing too consequential. This is basically the output of the height map for our sidewalls. So that's done. And then we'll do the profile on this surface here, which is, it's the exact same workflow as the Copernicus design for the rim, just throwing random shapes together really until I get something that looks good. Just play with it, have fun, really. So what I did here, just made a random chevron, moved it around, blended it, flipped it, blended it, dilate, invert, contrast, multiply. Again, these are very, very basic 2D operations, just playing with shapes, blurring them, putting them on top of each other. You really don't need much to get something interesting going, or something not interesting. I mean, if you look at this, you don't feel like this is going anywhere, but eventually it will. So I ended up with this after a tile pattern. And we need to get our islands in here, our UV islands. So we're doing a SOP import of the tire, rasterizing it to UV space, and rasterizing geo again. So now you can see we have our UV islands inside of COPS, and we have ID attributes that we're outputting. So this is 0, the big one, 1, 2, 3. And now you can do an ID to mask, and you can basically scroll through your ID patterns to select the UV island that you want to work on. So we're working on the big one for this, and I just need a mask so that I can apply my texture to it here. I wanted a little bit of fall off towards the edges, which I will show in the video once more. I guess it doesn't really show here, but this design doesn't abruptly cut off at the edge here. It has a little bit of bleed into the side of the tire, which I liked. So I'm just setting that up here with a little ramp. So all you need is a gradient over here and a gradient over here. And you just multiply them with the original design. And now you have a tiny fall off towards the edges. And that's really it. I'm sharpening it. There you go. And that's our height map for the main profile. So all that's left to do at this point is to displace it. We're using the exact same setup as before. Just flip this around. Dive in. Sorry, let me just up the subdivisions on this a little bit because this is, can't look at this. All right, and let me turn down the amplitude on the peak effect a little bit. There you go. So there you have it. I'll show the point VOP just in case. Give it a second. So again, same thing as before, except we're bringing in 2 textures instead of 1 this time. So here's our tire output. Here's our, here's our sidewall output, and just adding them together. Displace along normals. This time we're not using the y-axis, but we're using the normals of the actual mesh because those are looking good. And instead of just one parameter for the amplitude, we have the parameter and we have the mask, which is the Pyro sim basically. So our amplitude is multiplied by the mask. So wherever the Pyro sim hasn't burned yet, that's value is going to be 0. Anywhere else, it's going to be between 0 and whatever it is. And you displace it. Soften the normals. just to get rid of those very, very nasty, tiny, invisible to everyone but me, creases here. Soft normals will take care of that. And then I'm just gonna promote my UVs back to vertices so that we can do proper shading, lighting, rendering in your package of choice. I'm not gonna go over that part in this video because it's fairly basic, and I didn't end up rendering this in Houdini, so I don't want to get in trouble here. The rim's a little bit off, but you know, you get the idea. So yeah, I hope that was useful. I hope you learned something. I hope you guys have some tips for me as well on how to optimize this, especially the COPS alignment part with the UVs. I mean, it's a bit of a workaround, but I feel like there has to be a better way. More than anything, I hope this has showed you how much fun you can have with Copernicus, just playing with the settings and seeing what happens, and keeping in mind that it has its place in a modeling workflow as well. You don't have to go in here and be difficult about all this stuff. You know, if you're happy with how this looks, which I was, then who cares about poly modeling and creasing and subdividing and making sure everything's correct? Too much hassle. All right, guys. See you next time. Thanks.